Welcome to The Explainer. Today, we are going on a seriously mind-bending journey that is going to completely shatter how you view the universe. You know, we all kind of grew up assuming that if life exists out there, it just has to be on a calm, blue world exactly like ours, right? But what if the cosmos is way stranger than that? What if the absolute most likely homes for alien biology are chaotic, violent places that totally defy imagination? Today, we're exploring the bizarre reality of exoplanets, and we are heavily focusing in on the incredibly strange twilight zone of Proxima b.
Okay, let's dive into this. Could life actually survive in perpetual twilight? See, we have this massive Earth-centric bias when we imagine a habitable planet. We're totally used to our comfortable 24-hour cycle of warm days and cool nights. But as we scan the galaxy, we're quickly discovering that the conditions for life might not require a sunny beach and a gentle breeze. Honestly, they might just require a delicate, completely bizarre balance right on the edge of utter extremes.
Section 1. Our closest alien neighbor. To really grasp how extreme things can get out there, we first need to realize just how unbelievably lucky Earth is when it comes to planetary stability. As astrophysicist Brian Cox points out, our own solar system is actually incredibly hostile. I mean, you can't just hop over to Venus. It's literally a 400+ degree melting pot with 90 times our atmospheric pressure. You'd melt and be crushed pretty much instantly. The window for life as we know it is incredibly narrow, which really makes Earth this rare, beautiful exception. So what happens when we look at the closest star system to us?
Well, this brings us to Proxima b. It's an Earth-sized rocky planet orbiting our nearest stellar neighbor, Proxima Centauri. And its orbit is a shockingly tight 0.05 astronomical units. Basically, that means it is just 5% of the distance between the Earth and our Sun. To put that into perspective for a second, that is much, much closer to its star than Mercury is to our Sun. I mean, it is practically hugging the thing.
Section 2. The Red Dwarf Threat.
Now you might be thinking, wouldn't a planet that close incinerate instantly? Well, that depends entirely on the star. And Proxima Centauri happens to be a red dwarf. So the crucial point is, red dwarfs are absolutely not the calm, warm, yellow suns we're used to. They are violent. They're temperamental. They're prone to massive star spots that can literally cover half of their entire surface. Plus, they undergo these sudden bouts of rage, flooding their local environments with electromagnetic plasma storms and intense radiation. Any planet orbiting this close is being put through a terrifying gauntlet.
Section 3. Trapped in tidal lock-in.
Because of this extreme proximity to such a volatile star, Proxima b faces a massive physical problem driven by intense gravitational forces. It's called tidal locking. If you're not familiar, this is a gravitational phenomenon where a planet's rotation syncs up perfectly with its orbit. The end result? One face of the planet is permanently pointed directly at the star, while the other faces out into the freezing cold void of deep space. If you were standing on Proxima b, the sun would never set, and it would never rise.
This creates a wildly stark, brutal dichotomy. On one side, you've got this scorching desert day side, just baked under perpetual, roasting starlight. And then, on the exact opposite side, you have a frozen wasteland night side, completely trapped in eternal darkness, where the atmosphere itself could catastrophically freeze and collapse. When you look at these two extremes, it honestly seems utterly impossible for life to exist here.
Section 4. Enter the Ribbon World.
But the universe is incredibly clever, and this is where we reach the most fascinating part of this explainer: how life could actually survive this nightmare scenario. The answer actually connects science fiction straight to science fact. Now, what's really interesting about this concept is how the visionary sci-fi author Arthur C. Clarke popularized the idea of the ribbon world. It's an incredibly elegant solution to the seemingly unsolvable problem of a tidally locked planet. The key to a ribbon world is the Terminator line, or as it's often called, the twilight zone. This is a super thin, localized strip girdling the entire planet, right at the boundary where the blistering day meets the frozen night. In this narrow little oasis, heated from one side and cooled by the other, the temperatures could miraculously balance out.
Obviously, it requires a highly delicate balance, but computer modeling has actually shown that if the planet has a thick enough atmosphere and liquid water, it can circulate heat all the way across the globe. This dynamic weather system would keep the day side from completely roasting and, crucially, prevent the night side's atmosphere from freezing solid. In that perpetual twilight ribbon, an entire alien ecosystem could theoretically thrive. How wild is that?
Section 5. Beyond Earth-like expectations.
Let's move on and see how this builds, because as strange as Proxima B's ribbon world sounds, the universe has even weirder tricks up its sleeve to broaden our understanding. 3,200 degrees Fahrenheit. Just think about that number. That is the blistering surface temperature of an ultra-hot super-Earth known as TOI 561b.
By literally every rule of astrophysics we thought we knew, a rocky planet this small and this insanely hot should just be a bare rock. Its atmosphere should be completely burned away. But James Webb Space Telescope data suggests TOI 561b actually has a thick atmosphere right above a global magma ocean. Researchers are calling it a wet lava ball. It is constantly burping out gases from its interior magma, which completely upends our understanding of how rocky planets hold on to atmospheres under extreme conditions.
And this brilliantly illustrates just how dynamic these alien atmospheres can be. The JWST recently observed the hot Jupiter WASP 94ab, located about 700 light-years away, and mapped out a wild daily weather cycle. On this planet, the mornings are packed with thick clouds made of magnesium silicate, literally rock clouds. But as the atmosphere rotates and temperatures spike over 1,000 degrees, those rock clouds just vaporize, leaving the evening skies completely clear.
Then we have TOI 5205b. This one is a Jupiter-sized gas giant orbiting a tiny red dwarf star. To visualize this, imagine a pea orbiting a lemon. Based on our old models, a tiny star shouldn't even have enough material in its disk to form a planet this massive. Plus, it's incredibly carbon-rich but metal-poor on the outside, while its interior is 10 times more metal-rich. This quote-unquote impossible planet is actively forcing scientists to completely rewrite the absolute limits and rules of planet formation.
Section 6. The future of habitability.
So, all of these impossible planets, from wet lava balls to rock cloud giants, bring us right back to our ultimate quest, the search for life. The key takeaway here is that we absolutely must embrace the universe's endless variety. We are actively redefining planet formation rules as we speak. With tools like the James Webb Space Telescope mapping alien atmospheres with unprecedented precision, we're finally looking well beyond our Earth-centric biases. If we want to find extraterrestrial biology, we simply have to expand our definition of what a habitable world actually looks like. Which leaves us with this final, thrilling question to ponder. Are our own Earth-centric biases holding back the discovery of life? And if biology did find a way in the perpetual twilight of a ribbon world, what would that civilization actually look like? The answers are out there, hidden in the data, just waiting for us to expand our minds enough to see them. Thank you so much for joining me on this explainer, and remember, keep looking up.